Hello students. In the last video, we defined isomorphism as well as we understood the isomorphism with the help of graphs, two graphs. So now let us solve a few problems on isomorphism. Yeah. So first problem, let us verify that the two graphs are isomorphic. So G1 is given by this graph, G2 by this graph. Okay. Yeah. Fine. So now, in order to verify the graphs, to verify the two graphs are isomorphic, let us see all the four conditions are satisfied or not. So let us consider the first graph. How many vertices are there? So order of G1 is equal to 8, and order of G2 is also equal to 8. So you can see that A, B, C, D, P, Q, R, S. Here in this graph, in this graph you have A dash, B dash, C dash, D dash, P dash, Q dash, R dash, S dash. Hence, there are 8 vertices in G2. Therefore, the order of G1 is equal to order of G2. First condition is satisfied. Then the second condition. How many edges are there in graph G1? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So size of G1 is equal to 12. Similarly, if you see G2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Here one edge should have been there. I'm just writing. Yeah, 12. So size of G2 is equal to 12. Okay. So now the degree sequences. So the third condition is degree sequences. Degree sequence of G1 is equal to. So what is the degree of A? 3 edges are incident to A. So it is 3. Degree of B is also 3. Degree of C is also 3. D is also 3. P. Degree of P is 1, 2, 3. Degree of Q is 1, 2, 3. So all the vertices have degree 3. So 8 times 3. This is the degree sequence of graph G1. And if you consider degree sequence of graph G2, it is also the same. So 3, 3, 3, 3, all are 3. Okay. Next, we need to see the one-to-one correspondence. Okay. One-to-one correspondence between the graphs. So let me just write the vertices of graph G1. A, B, C, D, E, F, A, B, C, D, P, Q, R, S. Now, A is a vertex of degree 3, which is adjacent with 3 vertices of degree 3. Okay. Now, in graph G2, A dash is, let me start from A dash. So, A dash is of degree 3, which is adjacent to 3 vertices of degree 3. Hence, I can map easily A to A dash. Okay. So within brackets, I'll just write for my convenience. I'll just write this as A. Okay. Now in graph G1, A is adjacent to B, A is adjacent to D, A is adjacent to P. So in graph G2, A dash is adjacent to B dash, A dash is adjacent to D dash, A dash is adjacent to P dash. So I can easily map B dash to B. B is corresponding to B dash, D corresponds to D dash, and P corresponds to P dash. So there is a one-to-one correspondence between B dash, D dash and P dash. Okay. So I'll just name it here. So D corresponds to D dash, P corresponds to P dash, and B corresponds to B dash. Okay. Now C. Okay. B is a vertex of degree 3. So what is B in graph G2? It is B dash. B dash is also the vertex of degree 3. Now B is adjacent to A, B is adjacent to C, B is also adjacent to Q. So B is adjacent to A in the sense B dash is adjacent to A dash in graph G2. So that is there. There is an edge. Now B dash is adjacent to Q dash, B dash is also adjacent to C dash. Therefore, I can see the one-to-one correspondence between C and C dash. Okay, so C dash corresponds to C and Q dash corresponds to Q. And therefore, C corresponds to C dash, Q corresponds to Q dash. Now we are left with the two vertices R and S. So R is adjacent to C, R is adjacent to Q, R is adjacent to S. Now your Q is Q dash, C is C dash. So C dash and Q dash are adjacent to R dash. Okay, and R dash is adjacent to S dash. And therefore, R dash corresponds to R and S dash corresponds to S. And therefore, R dash, S dash. R corresponds to R dash, S corresponds to S dash. So we have seen a one-to-one correspondence between the vertices. Okay. Now, how to see one-to-one correspondence between the edges? That can be easily obtained with the help of, you can easily verify whether the correspondence is correct or not with the help of the adjacency matrix. With the help of adjacency matrix. See, now we have a G1 and G2 matrices. So every row of G1 is labeled with by the vertices of G1 as A, B, C, D, P, Q, R, S. Now we know that A, B, C, D, P, Q, R, S are corresponding to A dash, B dash, C dash, D dash, P dash, Q dash, R dash, S dash. So label the rows and the columns of the second vertex for G2, the adjacency vertex of G2 by these vertices A dash, B dash, C dash, D dash, P dash, Q dash, R dash, S dash. Now, A in graph G1, A is incident to B, adjacent to B, adjacent to P, A is adjacent to D. So, I'll just put 1 for AB, then AB, AP and then AD. Remaining all, it is 0. Clear? Next, B, vertex B is adjacent to A, B is adjacent to C, B is adjacent to Q. So, BA is 1, BC is 1, BQ is 1, remaining all, it is 0. Then, C is adjacent to B, C is adjacent to D, C is adjacent to R. So CB, CD, CR takes the value 1, remaining all 0. Similarly, D is adjacent to C, D is adjacent to A, and D is adjacent to S. So DA is 1, DC is 1, and then DS is 1, remaining all zeros. Okay, next A is A is over. P is adjacent to A, Q and S. A, Q, S, remaining all 0. R is adjacent to Q is adjacent to P, R and B. Q is adjacent to P, B, R, P. Next, R is adjacent to Q, C, S. C, Q, S. And S is adjacent to D, R, P. D, D, R, P. S is adjacent to D, R, P. Remaining all 0. Similarly, if you try to write the adjacency matrix for G2, A dash is adjacent to D dash, P dash, B dash. A dash is adjacent to D dash, P dash, B dash. Remaining all zeros. Then B dash is adjacent to A dash, Q dash, C dash. A dash, C dash, Q dash. Remaining all zeros. C dash is adjacent to R dash, D dash, B dash. B dash, D dash, R dash. Similarly, if you write for all the other vertices, you will get the same matrix like this. Yeah. One, zero, 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 0, 1. Then 1, 0, 0, 0, 0, 1, 0, 1. 0, 1, 0, 0, 1, 0, 1, 0. 0, 0, 1, 0, 0, 1, 0, 1. 0, 0, 1, 0, 1, 0, 1, 0. So this implies, you can see the compare the adjacency matrices. This implies that G1 and G2 are isomorphic. So we shall consider another example in the next video. Thank you.